lesson friction. In our previous class, we learned about that what is the friction, the causes of the friction, and the factors affecting the friction. Now, in today's class, we will learn about the types of that the friction. Okay, so there are the four types of that the friction: the static friction, the sliding friction, the rolling friction, and the fluid friction. There are the four types of that the friction. First, we recall that what is the friction? The friction is the force which opposes the motion of the object, right? So we will see that these types. So one by one we will start it. So first is the static friction. Now, what is the word static? In our lesson force and the pressure, we learn about that the electrostatic force, right? So what do you mean by the electrostatic? Electro means the charges and the static means rest position. Okay, means the charges which are at a rest are called the electrostatic. So here also the word static means the stationary, which is at the rest. Okay, so here the static friction is here. So from it's a word, we can simply say that the static means the object is at a stationary position. Now, if I want to push this box towards the right side, and this box is really very heavy, then what happens? If I give a initial push to it, then nothing will happen. Okay, it not move from its initial position. So why it not move from its initial position? Because the because due to this static friction, we know that the friction always opposes the motion of the body, right? Whenever I am given a force from this direction to move the body towards the right, then the frictional force always opposes this motion. And here the body is at its rest position because the static friction acts from the opposite direction of the applied force. Okay, so the static friction is the force which keeps the object at rest, which will not allow the object to move from its initial position. Okay, it is a self-adjusting force, means it balanced the force, whatever the force you applied, and the static friction or the frictional force, both are the balance and the body is not able to move further. So in this force, there is a no actual movement of that the object. Means the force of static friction is always equals to that the applied force. And when the condition is a balance, then the body is not able to move from its initial position. Okay. So it always acts in the direction opposite to that of the applied force. Means whatever the force you applied, the static friction always acts from this the opposite direction. And if you want to overcome the static friction, then you require a lot of force to overcome this friction. Okay, so the static friction is simply the frictional force which keeps the object at rest. But what happens after a few seconds if you are continuously push the object with a greater force? Then after some time it start its moving, right? So exactly what happens then with this the static friction, we will clear it or we will understand it with the help of this graph. Consider that we take a two axis. Okay, there is a one x-axis. On that x-axis we consider the applied force, means which force we will give to this object, and on the y-axis we consider that the frictional force. Now what happens when you give the push force, then the same time the frictional force also increases. Okay, means you give a greater force, the frictional force also opposes this the force. But this happens up till a certain limit, up till a particular point. Means at due to this condition, means the condition is balanced, then the static friction is there. But after some time, it starts, it's moving, and the another friction comes into role called the sliding friction. Okay, means when you are giving a force, applied force, then the static friction also increases, but at a particular point, after this point, it starts moving, and this position from where it starts moving, then the friction also changes, and the another friction comes into role called the sliding friction, right? So what is exactly the static friction, sliding friction here? So the sliding friction is also the one type of like the frictional force which opposes the relative sliding motion between the two surfaces in contact. We already learned that the frictional force is a contact force and the two bodies must be in contact with each other, right? So whenever there is a sliding friction, the two surfaces must be in relative motion with each other. Consider that if I want to push this box onto that on this floor, okay, then there is the relative motion between this box and the floor. Now if I want to move this box, then opposes the uh, who opposes this force? Then of course the sliding friction opposes the force. Okay, so the sliding friction opposes the motion of that the moving object, or we can say that the sliding motion of that the object. So here the resistive force or the opposing force is the sliding friction, which opposes the motion of the moving object. Okay, if I want to drag some heavy bag, then who resists this motion? Then the sliding friction opposes this motion of that the object. Okay, also the sliding friction is always less than the static friction. Why this happens? See in this graph also, if you notice that, you notice here that the this line is in the low direction. Why it is in the lower side? The sliding friction is at the lower side than the static friction, because the sliding friction is always smaller than the static friction, because when the body is in a motion, then you require the less force to move it. But when the object is at the rest position, and if you want to give the motion to that the rest object, then it is difficult to give the motion. You require a larger force to give it a motion. But if any object is already in a motion, then it is easy to move it from its initial position, right? So that's why the sliding friction is smaller than the static friction. Okay, and sliding friction is also called the kinetic friction. Why it's called the kinetic friction? Because the object is already in a motion. That's why we say that the sliding friction also the kinetic friction. Why this happens? When the it is we and as I already said that it is easy to give the motion to the moving object, but it is difficult to move the stationary object. And the chances of the interlock, okay, is also less in the sliding friction, because the object is already in a motion. So the chances of the interlock between the two surfaces is less. But in the static friction, the object is in a rest position, so the chances of the interlocking is also increases. And if there is an interlocking is greater, then it's not able to move the object from the its position. Okay, so that's why the chances of the interlocking is less in that the sliding friction than that of the static friction. And it is also, you also know that it is easier to push a moving car, right? Because it is already is moving, you require a less force to move it. But it is difficult to push a car which is standing, which is at a rest position. So that's why the sliding friction is always less than the static friction. Okay, now the next friction is the rolling friction. Now consider that if there is one box which I kept on that on this table, if I want to move this box from this rest position, then what I need? What do I need? I need to apply some force to this box to move from its position, right? Similarly, if I take a same box, but these box have some pencil rolls under it, okay, and I want to move this box from its position, then again I need to give some force to this box also, okay. But what happens in these two cases? Who requires a less force? So of course you can also tell that the second one condition means the box which have the cylindrical rolls or the pencil rolls under it requires a less force to move it. So why this happens? Why we require a less force to move it? Similarly, if you traveling from one city to another city, then you carry a luggage. Okay, consider that if you carry the luggage of nearly 30 kg is it? Okay, so it's not possible to carry it easily. Okay, so at that time you drag it. Whenever you drag it, then the sliding friction comes here, right? You are drag it, but still you require a larger force to drag it. Okay, but if you use a bag which have a wheels to it, then it is easy to move it, right? So why this happens? Why the all these happens? Why it is the easy to move the object which have a wheels under it? Why it's a difficult to move the object if they don't have any wheels under it? Okay, it is also possible to move it, means you have to drag it, but you require a larger force comparison to that. This. In this the previous case also, in these two conditions, here the same box on the same surface, here also the same box on that the same surface. But the only difference is that this box don't have a wheels, but this box have a wheels under it. Okay. So the lesser force required to move it. Okay, because they have the cylindrical rolls under it. So the frictional force comes here, which is the rolling friction. Now, what is the rolling friction? So, the rolling friction is the frictional force on the object when the object rolls over a surface. Okay. How the rolling is possible? If there is some cylindrical surface under the object, then the rolling is possible on that particular surface, right? So the rolling friction is the frictional force on the object when the object rolls over that the surface. And the rolling friction is always less than the sliding friction. Why? Because it is easy to move the object which has the cylindrical type wheel, cylindrical type rolls. Okay, in our previous case, we clear that it is difficult to move the bags which don't have the wheels, but it is easy to move the bags which have the wheels because it is easily roll on that the surface, and it is difficult to it is a slide. Okay, means here the frictional force is the sliding friction, and in this case the frictional force is the rolling friction because it is slide on that the surface and it rolls on that the surface. Okay, so in this case, the chances of the interlocking is a more less. Okay, is again less than that of that the sliding friction. That's why the rolling friction is less than the sliding friction. Okay, so shortly we will see what is exactly the static, sliding, and the rolling. We compare it. So the static friction is the friction which keeps the object at rest, right? The sliding friction is the friction on the object when the object is moving, right? When the object is moving over a surface. It is lower than the static friction, but it is higher than the rolling friction. And the rolling friction is the frictional force on the object when the object rolls over the surface, and it is the lowest than the frictional force, right? Means the static friction is greater than the sliding friction, and the sliding friction is greater than the rolling friction. The very least is the sliding static friction. Means the static friction is the highest frictional force, then the sliding friction is less than that the static friction, and the rolling friction is the least one. Okay, means the static is the greatest one, then the sliding, and then the rolling friction. If any object have the wheel under it, then it is easily moved from one place to another place, right? But and if any object is already in motion, then it is also easy to move because it is already in motion. But it is very easy when it have a rolls under it or the wheels under it. But it is very difficult to move any stationary object from its initial position. That's why When the object is at a stationary position, then the frictional force is a more, and this is the static friction, and then the sliding, and then the rolling. Okay. Now, see here, if there is a no motion, means there is a static friction. If there is a sliding motion, once the motion is already present, then there is a sliding friction. And then there is a rolling motion, then this friction is the rolling friction. Means the rolling friction always requires some cylindrical like shape, and then there is the particular object. The sliding friction, the object which is already in a motion. And in the static friction, the object is in a rest, means there is a no motion. Okay, so these are the three types of the friction: static, sliding, and the rolling. Now next is the fluid friction. Now what is the term fluid? We know that the forms of that the matter. Okay, the states of the matter. There are the three states of that the matter: solid, liquid, and the gases. Okay, so the word of fluid is the common name given to that the liquid and the gases. Means up till now we learn about that the solid friction. Solid friction, or we can say that it is a dry friction, right? But now we will study the fluid friction. Means in fluid friction, the liquid and the gases come together. Okay, so the fluid is the common name given to that the liquid and the gases. Now, as we already learned about that, the frictional force offers the solid, liquid, and the gases. But the frictional force is a maximum in the solid, and the frictional force is less in that the liquid. We learn that, see, the exactly what is the fluid friction then? The frictional force exerted by liquids and gases is called the fluid friction. Now, when we swim in the water, then of course the water opposes earth. Okay, opposes the motion of our body. This is the frictional force acts in the body, and this frictional force is nothing but the fluid friction. Similarly, see here, the fish wants to swim, or it continuously swim in that the water, but there is some resistance of the water to stop its motion. So this resistive force which acts in that the water is the fluid friction. Similarly, in a air, the aeroplane moves. Okay, it also opposes the motion of that the aeroplane also opposes by the air. Means in the air there is a air resistance, and in the water there is a water resistance. So the whatever the resistance or whatever the frictional force which opposes the motion in the water and in the air is called the fluid friction, or sometimes it also called the drag force or the drag. Okay. Now some factors which affect this fluid friction. So there are the three factors which affect the fluid friction. First is the nature of the fluid. Second is the speed of that the object, and third is the shape of the object. Now, one by one, we will see what exactly happens in that the nature of the fluid. Consider that if I hold a one object in a water, and at the same height in the air, at the same position, I hold the another object. Okay, and I want to give the motion to both these objects in the water also and in the air also. Then whose motion is faster? Who moves faster? The object present in the water or the object present in the sky? So, of course, the speed of the object or the motion of the object which is present in the sky is greater comparison to that of the liquid. So, why this happens? Because the liquid is more viscous. Viscous means or the thickness of the water is more comparison to that of the air. Okay, if the fluid is more viscous or it is more thick, then there will be the more friction. Means it opposes the motion of the body more, right? And if the fluid is less viscous or thin, then there will be the less friction. So the viscous means the fluid's resistance to flow. Means in the water, who resists the motion of our body? Of course, the water opposes the motion of the body. So the viscosity, we can say that it's the one type of the resistance which offers by the liquid. Okay, so the object who is more viscous then the frictional force is more there. The comparison, when we compare the viscosity of the water and the air, then the water is more viscous comparison to that of the air, and that's why the speed of that the boat is less than that the speed of the aeroplane, right? The aeroplane reaches very quickly because its speed is more and it's a less viscous, it is a thin, but the boat requires a more time to reach from one place to the another place, and that's why we, when we want to go emergency somewhere, then we use the flights, we use the planes to go through, we use the planes to go from one place to the another place because they have the less viscous, okay. And if the viscosity is more, then the frictional force is more, and if the viscosity is less, then the frictional force is also less. And when we compare the honey and the water, then the honey is the more viscous, okay. And in the honey, the frictional force is more, and in the water, the frictional force is the less. But when we compare the water with the air, then the water affect the or the frictional force more in the water, and the frictional force in air is the less. So it is the one effect of that the friction, fluid friction, which is the nature of the fluid. Nature means it is more viscous or not, or the thickness we can say. The second is the speed of the object. If the speed of the object is more, then the fluid friction is more. If the speed of the object is less, then the fluid friction is less. Like that here the speedboat. The speedboat have a more speed. Then the fluid friction is also more here. Okay, means the water opposes its more. And in the paddle boat, the speed of the paddle boat is less, and hence the fluid friction is also less here. Means the resistance of the water is less in the paddle boat, but the resistance of the water is more in that the speed boat. Means if the speed of an object is greater, then the friction is also greater. Fluid friction is also greater. And the speed of the object is less, then the fluid friction is also less. Okay, so this is the another factor. On the speed, the fluid friction also depends. And the next one is the shape of an object. What is the shape of an object? The fluid friction is also depend on that. If the object is a streamline means whose front is a pointed like the fish, okay. The body of the fish is a streamline structure, okay. You also consider that the shape of that the planes is also like that of the fish. Why? Because if the shape of that the object is a streamline, then they face the less friction, less fluid friction, and it can easily move. Okay, but if the object is not a string, then it faces the more friction, like that the truck and the car. The truck structure or the shape of that the truck is like that the rectangular. It's not a streamlined body. The its a front is not a pointed, but the shape of that the car is like a streamline, and it faces the less friction. Okay, means we can easily move, but the truck faces the more friction, and that's why the plane, the birds also have a streamlined structure on their body because they can easily move. They face the less friction. Okay, so this is the reason behind that. So the fluid friction depends on these three effects. One is the nature of that object, second is the speed of that object, and third is the shape of that object. Okay, so in today's class, what we learn about that the four types of the frictional force: static friction, sliding friction, rolling friction, and the fluid friction. Right. So the static friction is the greatest friction. The rolling friction is the is the less friction. Okay. And the sliding friction is in between that the static and the rolling. Okay. Means the static friction is the greatest friction or the highest friction, and the rolling friction is the lowest friction. Okay. Now, in today's in a next class, we will learn that the how we reduce the friction, what are the advantages and disadvantages of the friction.